Today we're taking a look at some sample problems on section 11.3, which deals with conditional probability and events involving the word and. And we'll begin with number 2. It says, for each experiment, determine whether the two given events are independent. Independent events, remember, mean that the outcome of one event in no way affects the outcome of the next event. So events would be independent. For example, if you're doing an experiment with replacement, if you're talking about cards or drawing M&Ms or drawing marbles, you put them back, then they're independent. They are dependent if you do it without replacement. So that means when you draw a card, draw a marble, draw an M&M, you do not replace it. They are not independent because the outcome of the first draw does affect the outcome of the second, third, and so forth. So in these first few, we're trying to figure out whether the events are independent. A pair of dice in number 2, a pair of dice are rolled. The events are even on the first and odd on the second. So we have 2 dice, and the question is, are the rolls of the 2 dice independent? And the answer would be yes, those are independent. Certainly whatever we get on the first die in no way affects what we get on the second die. What we get on the green one doesn't affect what we get on the red one. All right, let's go down to number 6. A committee of 5 is randomly selected from the 100 U.S. senators. The events are the first member selected is a Republican and the second member selected is a Republican. And we're to assume that there are both Republicans and non-Republicans in the Senate. So if we're selecting a senator, we're not replacing that senator, so we would have fewer people to draw from. So those would not be independent events, because on the first draw it would depend on whether we got a Republican or not. Okay, now we go to a table and we'll look at number 8. We're talking about primary career motivation. We have money, allowed to be creative, or get sense of giving to society. So number 8, we ask if one of these students is to be selected at random, find the probability that the student selected will satisfy each condition. And in number 8, it's motivated primarily by creativity. We have no restrictions on that, so we're looking at 38 out of 100. Total number of students is 100. We can reduce that to 19 out of 50, or you could write it in its decimal form, 0.38. Okay, number 12, motivated primarily by money or creativity, given that the student is female. So we have a conditional probability, and remember that we restrict our attention to the given portion. So that's going to tell us our denominator. Given that the student is female, how many females do we have in all? We have 52. We want to figure out how many of those are either primarily motivated by money or creativity. And I see 12 plus 23 would be 35. So we have 35 out of the 52. Okay, turning the page, we're looking at a pet store that has 7 puppies, including 4 poodles, 2 terriers, and 1 retriever. If Rebecca and Aaron, in that order, each select 1 puppy at random with replacement, that means they both may select the same one. So they're just selecting the dog, petting it, and then putting it back. Find the probability of each event. 14, we have Rebecca selects a retriever Aaron selects a terrier. Okay, let me put the numbers up here. We have 4 poodles, 2 terriers, and 1 retriever. Okay, so Rebecca selects the retriever. That's a total of 7. Would be 1 out of 7. And that dog is put back, and then Aaron selects a terrier. That would be 2 out of the 7. So we get 2 out of 49. Okay, next one, we want to go down to 18. This time, we're selecting 2 puppies, but without replacement. So in 18, Aaron selects a terrier, given that Rebecca selects a poodle. Aaron selects a terrier. So we're just talking about Aaron's selection. So Rebecca has selected a poodle, so a poodle is removed from the mix. We now only have 6 dogs, and so that means Aaron would only have 2 out of the 6 are terriers. Oh, my pen is not working too well here. Let me erase it and try again. There we go. Okay, 22. Both select a retriever. Okay, well, on the first selection, Rebecca could select a retriever. On the second selection, there are no retrievers left because one's been removed. So it is impossible for them to select, both of them to select retrievers if we're not replacing them. All right, 24. We're dealing 2 cards successively without replacement, so that's the important part. Find the probability that we get a club second, given that we got a diamond first. Okay, so we have the 52 cards. A diamond has been removed, and the probability of getting a club second, there's still 13 clubs. There's only 51 cards left, so it would be 13 out of 51. Okay, and then the next one, we're drawing 2 cards. We want to know the probability of getting 2 cards that are not face cards. And remember, we have King, Queen, and Jack times 4 suits, so that's 12 face cards. So 40 cards are not face cards. So in the first draw, it would be 40 out of 52. Now we've removed a card that is not a face card, so now we have 39 out of 51. And let's see if we can reduce this. I believe we can. 13 will go 4, 3. 3 will go, is it 17? 4 will go 10. So I'm getting 10 17ths for that after I do all my reducing. Okay, let's look at, we're still working on cards. Use the results of exercise 28. I don't like what they do in 28, so we're just going to do it by the process of just reasoning it through. So, probability of a face card, we're drawing a single card from the deck. Probability of having a face card if we have drawn a queen. So you've got somebody who's saying, hey, you've drawn a queen. What is the probability it is a face card? Well, if it's a queen, it's automatically a face card. Okay, and 32, the probability of it being a diamond if someone tells you that you've drawn a red card, given that it's red. Okay, so that reduces our attention to the 26 red cards, and 13 of those are diamonds. So we get 1/2. Okay, and 35. The two authors of this book each have 3 sons and no daughters. Assuming a boy and girl babies are equally likely, what is the probability of this event? 3 sons and no daughters. Okay, for the first one, to have 3 sons, and the second one, so we continue multiplying to have 3 sons. That's 1 out of 2 to the 6, which I believe is 64. Okay, maybe running off the edge a little bit there. 1 out of 64. Okay, the last group we're doing is probabilities in warehouse grocery shopping. We have Therese Felser manages a grocery warehouse which encourages volume shopping. Therefore, they have discovered that on any given weekday, 70% of the sales amount to more than 100. Okay, so probability sales greater than 100 is 0.7. X equals sales. Okay, that is any given day has probably a 0.7 of being more than 100. So probability X is less than or equal to 100 would be 0.3. All right, so let's look at 38. The first 3 sales on Wednesday are all for more than $100. That would be the first sale, the second sale, and the third sale. So we get 0.7 to the third. And I'll use the calculator for this. We get 0.343. Alright, and number 40, our last problem that we'll do here. Exactly 1 of the 3 sales on Wednesday is for more than 100. So we have the first one, and then we have the second possibility. Notice we could have the sale for more than $100 be the first, second, or the third sale. So those are the possibilities. So 0.7 times 0.3 times 0.3 is 0.063. So we want to add these together, or take 0.063 times 3. I'm getting 0.189. So what we're saying here is the sale for more than $100, that one sale could be the first, second, or third sale. Okay, so I think that should give you enough to get you started on the assignment for section 11.3.